All right, this time on Working Class Dog Garage, we are going to put bearings in a single phase motor. This motor is off of actually this table saw. I bought this for $50 off of, I believe it might have been Craigslist, back back before Marketplace, or at least before I knew about Marketplace. Um, the saw is in just kind of fair condition overall. Someone had put a different motor on it, but it was the wrong RPM. It was a 1750 RPM motor, which is pretty slow for a table saw. Typically, they're 3400, so at the blade speed, somewhere between like 3600 and 4000 RPM. So it was a good running motor, but I took that off. I found this one on, but this one was off a Marketplace. This is a 1.5 horsepower, 3400 RPM or 3450 RPM motor, off of a pressure washer. You can see it has the C face mount on it here, where the pump mount, went onto it. Put that onto the table saw, and as I've been running, I've been noticing the bearings sound a little bit noisy. You can kind of hear if I spin it, they have a little bit of a growl to them. They're not bad. I could probably get a lot more life out of it, but I just kind of bothers me to listen to them, so I'd like to replace them. I actually did. I took the motor apart, and then I confirmed that it needed bearings, and I was like, this might be a good thing to video. There might be a lot of people that need to do this. So I actually, full disclosure, I put it back together, but I've not taken the old bearings out yet. That has to be done. So we're going to disassemble it and get the bearings out of it, and hopefully put some new bearings in. So we're going to take the pulley off the front here. I put a lot of never sees on there when I put it on the saw in the first place. I definitely subscribe to the theory of you want to be nice to the next guy, because the next guy is very likely going to be me. So make sure it's easy to get apart. This motor is, they call a totally enclosed fan cooled, or TEFC motor. It's what you want for an application like a table saw, where, oh gosh, it's heavy. There's going to be a lot of dust in the air. If the motor is open, typically call it open drip proof style motors, it's moving the cooling air right through the motor, and it's very likely that it's going to plug the motor up with sawdust, and you're not going to get much cooling at all. So that's why I picked this one. It was the right RPM. It's 1.5 horsepower, which is about the biggest you can get on a 110 circuit. I wanted that so I can move it around to different areas where I'm working. So that's how I ended up with this one. I think it's a Balder motor. It looks like the name. Well, I won't roll it over yet because I don't want to break the fan. But the nameplate looks like a Balder nameplate on it, but it is pretty faded. It is obvious that to look at it, this motor was on or in a location where it got wet pretty frequently, aka the pressure washer, because there's a fair amount of rust on it. You can see where there's been some moisture on the inside, but overall it's in pretty decent shape. Seems like a pretty well built motor, although I will say this plastic fan that just kind of clamps onto the motor shaft is a little bit I don't know, chintzy looking. Let's see if we can get this guy wiggled off without breaking it. There we go. So you can see it just clamps onto the motor shaft there, and sure doesn't seem like it would ever go anywhere, but I don't know, that just seems like that would be likely to crack in there. And I guess it's made it this far, so it's probably fine. Next thing that we are going to do is to take these long through bolts out, to take the end caps of the motor off. A lot of other motors, I should say small, small single phase electric motors like this that I put bearings in, they typically just have a through bolt and a nut on the end. This one actually threads into, I think it's a cast iron housing here on this end because of that. Again, this has the C-face mounting on it to mount the pump to. This could also be used if the motor is mounted directly to a piece of equipment. It could be mounted here and then not even use the base mount. But on the pressure washer, this one used both. The base to hold it to its little cart, and then the C-face mounted the pump to the motor. So we'll take these out. Take those out. And then I'm just going to gently tap to break the end cap off. And the end cap will slide out with the rotor in it. Gently as possible. There's a wave washer on the back there. And that is really all there is to it. That little rotor there produces 1.5 horsepower, at least according to the nameplate. These are the fly weights here for the centrifugal switch. Because it uses an additional winding when it first starts, and then once it comes up to speed, it disconnects that one and just runs on the run winding. We'll set that off to the side for a moment there. Make sure it's not going to get away. We'll see if this end will come off. And this end has the actual switch for the centrifugal switch attached to it, so the wires are there. But you can see in here, I think you can you? Yeah. The contacts are down here as that. As those flyweights come out and that retracts, it lets go of those and turns off the start windings. Contacts look nice and clean in this motor. I have seen where they can get corroded and cause problems with the motor starting. This motor has a bearing retainer here on the back side. Not a lot of small single phase motors, again, just that I've taken apart, have had that in it. So take these bolts out, let that retainer come loose. Okay. And then we can just a little tap tap. Take end cap off of there. keyway, or not keyway, key. It's coming out of the keyway. So these bearings aren't bad. Like I can barely hear anything when I spin them by hand, but you know, the front one you can hear a little bit. The back one is very quiet. So the front one is probably the one that really actually needs replaced. But obviously, while we're in here, we're just going to do both of them. You can see here there's some rust around the bearing, you know, and there's some evidence of rust on the inside. This definitely, you know, was damp or even wet, you know, at several points through its life as part of that pressure washer. And that might actually be what caused that front bearing to fail. But in any case, I'll put some new ones on it and I'll put it back together. If there's one part that's a little tricky about this process, it's that these bearings are pressed onto the motor shaft. So we're going to need to get those off of there. And it also looks like that is not pressed completely down onto that shoulder there, which is interesting. So I might have to kind of make note of that. So probably what I'll do is get a bearing separator on here and just stick this in my press and press this out. You can hammer them out, but it's just a little easier with the press. And then I'm going to try something that I haven't done before. I'm going to try heating up the new bearings in an oven to see if I can get them to just slip over the shaft without having to try to press them on. So we're going to see if that works. So I'll get those all set, and then we'll see if, or I'll get the press set up, get the bearings heating, and then we'll try to get them off there. So I'll be back in a moment. All right, so over here at the hydraulic press, I have a bearing separator. It's not a nice one, just a cheap Harbor Freight one I got years ago. We're gonna put that over the bearing this way, like so. Now this isn't the way you would want to do this if you intended to put these bearings back on, but because these are going to become scrap anyway, it doesn't really matter as long as we can get them off. So I'm going to lock this down into the bearing. This will only take an hour or two, it's okay. Just going to apply some pressure down, bring this down a little bit closer, and then I'll make sure that I'm centered. That's pretty good. You want to be ready to catch your oh, looks like there's a collar on there. That's interesting. So it had the bearing on first, and then there's a collar that goes on there also. So that's interesting. Guess that, what would that do? Not sure why they would have that on there. Unless it just would keep anything from pushing on the actual bearing, maybe? I don't know. I'll have to look on the assembly there. But anyway, we will turn this around, put the bearing separator on the back end, and then we'll pull that off. Use. Now, one thing that I probably should have done was, you can see how this shaft is rusty here. I probably should have taken some fine sandpaper and cleaned some of that rust off, but again, I know these bearings don't typically fit that tight, so I just wasn't all that worried about it, and they came off okay. Again, I think that one, this back one feels fine. I think that front one got water in it, and that's why they were sounding rough. All right, let's get the, I have the new bearings in the oven over there. I will clean this up a little bit, and then we'll see if we can get the new ones on. All right, so I'm just going to wipe some of the grease and stuff off of the shaft here, and all the never sees that I put on the shaft where the pulley was. And I'm just going to use a little fine sandpaper to clean any rust and stuff off of it, so that the new bearings have the best chance of sliding on as smoothly as possible. So this is 600 grit paper. Honestly, I'm not sure what the right thing that you're supposed to use to do this is, but I've used either 400 or 600 in the past, depending on how corroded the piece is that I'm working on, and it seems to work out just fine. Just go until the surface is nice and shiny. Come around and do the back end here. This is the end the motor cooling fan goes on. Just clean that up. I think this outer part's actually a little bit smaller diameter, but I'll clean that up too, just to be safe. So I looked up on the internet how hot you should make bearings, or shielded ball bearings for heating them up to put them on, and said not to go more than 150 degrees above the temperature of the motor shaft. So I have the toaster oven set for 200. Actually, it smells good in the garage right now. It smells like Pop-Tarts or bread or something. I have those heating up. They've been in there maybe 10 minutes. So maybe get a temperature reading on those. The bearings that I got were NSK bearings. They are 6203 ZZ, meaning shielded on both sides. There were some of the better bearings that I was able to find. The ones that are on it are actually USA made bearings, which in my experience just don't exist anymore. These are made in Japan, I believe. Yeah, made in Japan. But NSK is a pretty respected brand from what I understand. So I think they should hold up for the amount of use that I'm going to put to them. So let me grab some welding gloves, and then we'll see if those bearings slip on. Although the other thing I need to remember, this bearing retainer needs to go on first. Make sure I put that on the right way. This really should be cleaned up too a little bit. Alright, so put the bearing retainer on, so make sure we don't forget that. The sleeve went on over top of the bearing, so that'll go on next. I wonder if I'll have to heat the sleeve up, actually. Hopefully not, but so let me clean it a little bit so it doesn't get my nice shiny output shaft dirty. see. Survey says, yep, I'm going to have to heat that a little bit too. All right. All right, so we got the bearings in here. Take one out. Let's see. Ooh, they are toasty. Go on. Hey, look at that. It looks like the correct spacing for where it was. I guess there must be a little bit of a shoulder there. Cool. That worked. That worked really well. Let's see if we can get the one on the other end. Hey, right on it goes. Beautiful. That's awesome. Alright, so those can cool off a little bit. And I don't suppose that collar is warm enough yet to want to slip on there. Nope. Alright, so we'll let that get a little bit hotter and get that slid on as well. Alright, good news is the toaster oven is out of here and I have more room to work. Bad news is it doesn't smell like Pop-Tarts and bread anymore, but it will be okay. Alright, so now I think we can go ahead and put it back together. I did blow the inside of the motor out with compressed air just to make sure there wasn't anything foreign in there. Didn't look too dirty. Like I said, there's some evidence that it's been damp in there, but otherwise it looked pretty good. So I think we can go ahead and start putting this back together. So actually, first what we need to do is put this front cap back on. I probably should clean that out a little bit. I might put just a little bit of grease on that. This is just for corrosion protection, not for lubrication or ease of getting it in. Looks like they have this end cap cast in such a way that you could actually, could be drilled for grease fittings to lubricate the bearings, but obviously they did not do that on this motor. So I'll put this in. Hopefully that bearing will fit in there. Oh, I have it on there pretty crooked. That might be part of the problem. Let's try a gentle tap here. The bearing is cool now, so that shouldn't be an issue. Thank goodness for the advantages of working on a table saw. Tuck that down through there. There we go. These bolts back through. I haven't seen many, not that I work on that many electric motors, but I haven't seen many single phase motors that use a bearing retainer like this. Most of them are just retained between the end caps. You put the end caps on and bolt them together, and that retains the motor shaft. They do usually have that wave washer in them. But to see where the wave washer went. But that allows the motor shaft to expand a little bit without pinching the bearings in between. I guess this bearing retainer must be just to keep it to make sure it doesn't walk back and forth on the drive end. Maybe so it wasn't moving around in the pump drive or something. I'm not sure, but that's how they have this one set up. Now I have to find that wave washer. It's not in there. I better find it before I forget. Alright, let's see if we can get a temperature on this little sleeve in here. 220. Give it another minute or two. Since the I turned my little oven up to 300 degrees there, since there's no grease or seals or anything in that sleeve to worry about. We'll go ahead and get it hot to get it slid on there. I didn't bother to check the bearings with the infrared thermometer because I was watching Watch West work. He's a great dude. He's got a great channel, and he was saying that the infrared guns don't read well on reflective surfaces. You need almost like a matte surface. I think he'd put a paint or a chalk or something on his bearings to get a better reading off of them. I didn't bother to do that. Like I said, I had a feeling they'd go on pretty easily with just a little bit of heat. So I just set the temperature low here and gave that a try. So I'll pull that sleeve out and we'll see if it wants to go on here for us. Oh, went on part way. Alright, this is pretty Mickey Mouse. We're going to try this. We're going to take one of the old bearings and then a socket on the sleeve and see if I can drive that down. There we go. That should do it for us. All right, good news is the toaster oven is out of here and I have more room to work. Bad news is it doesn't smell like Pop-Tarts and bread anymore, but it will be okay. All right, so now I think we can go ahead and put it back together. I did blow the inside of the motor out with compressed air just to make sure there wasn't anything foreign in there. Didn't look too dirty. Like I said, there's some evidence that it's been damp in there, but otherwise it looked pretty good. So I think we can go ahead and start putting this back together. So actually, first what we need to do is put this front cap back on. I probably should clean that out a little bit because this front end cap has the bearing retainer in it. That has to go on first. And then I can push the whole thing, or push the rotor through the motor, and put the other one on. Make sure that this is clean as possible. I might put just a little bit of grease on that. Looks like they have this end cap cast in such a way that you could be drilled for grease fittings to lubricate the bearings, but obviously they did not do that on this motor. So I'll put this in. Hopefully that bearing will fit in there. Oh, I have it on there pretty crooked. That might be part of the problem. Let's try a gentle tap here. The bearing is cool now, so that shouldn't be an issue. Thank goodness for advantages of working on a table saw. Tuck that down through there. There we go. These bolts back through. I haven't seen many, not that I work on that many electric motors, but I haven't seen many single phase motors that use a bearing retainer like this. Most of them are just retained between the end caps. You put the end caps on and ball them together, and that retains the motor shaft. They do usually have that wave washer in them. I'll have to see where the wave washer went. But that allows the motor shaft to expand a little bit without pinching the bearings in between. I guess this bearing retainer must be just to keep it to make sure it doesn't walk back and forth on the drive end. Maybe so it wasn't moving around in the pump drive or something. I'm not sure, but that's how they have this one set up. Now I have to find that wave washer. It's not in there. I better find it before I forget. It was sitting right on top of that fan. It's probably actually a wonder that it didn't fall off when I picked that fan up. Yay. Alright, so clean that off a little bit. That end cap looks really clean actually, so I think we'll go ahead and slip the wave washer in there. I'm going to take this. Move this over this way. So hopefully you guys can see. I'll slip this whole thing through. Not to bang the rotor around on the motor windings. Get this started. Make sure that wave washer's still in place. It is. Get started into that end cap. Now the part that might be a little bit tricky is I need to get these started all the way through the motor and into the holes in the other end. So I might turn the camera off and come back once I have all these started. Alright, so with some wiggling and turning, I got the all the through bolts started. So I'm just going to get these tightened up. These are not big bolts, so I got to remind myself not to go too crazy on them. Oh no, I did not get that one started. Uh-oh. Thought I had them all started. There we go. Just gotta snug them up, crisscross pattern here. Alright, make sure it turns. Sounds like it does. The start stop switch always makes a little bit of a dragging noise at low RPM on these because it's pushing against those contacts there. I think before I put the fan on here, I'll start it up and just make sure that everything works well and just see what it sounds like. So nice and quiet. That's good. And here, click back to the start windings one more time. That's nice. That's so much quieter than it was before. All right, so let's sit it down. This way again. Let's get the fan back on. Exactly sure how far that needs to go on, so we'll just line this up and see where we're at here. That looks pretty reasonable. It's also flush with the end of the motor shaft there, which would make sense. snug. It's plastic after all. The end cap on. Probably be easier to do this if it wasn't sitting on that fan shroud. There we go. One of the nice things about these electric motors is they're so universal. They, within the same horsepower range, they typically all use the same size shafts and keyways. The mounts are the same. I mean, I was able to, this is the original mount that was with the saw, which was replaced with that 1 horsepower, 1750 RPM motor that I took off, and then I was able to replace it with this 1.5 horse. I thought I was going for a ride there. This 1.5 horse, 3400 RPM motor, same mount, same shaft diameter. They are just such nice universal industrial parts that it makes it really easy to swap stuff around. They all work pretty much the same, so generally they're pretty durable. I mean, I've gotten motors at farm auctions and stuff where the outside of the motor is all rusted and rough looking, and the fan shroud is bent, and I've taken them apart, put fresh bearings in them, and they've been really good looking on the inside, and then a fresh set of bearings in it, they run really well and they're good to go for a lot more time. What's that? We'll give it one more test run here with the fan on, see how it works, and then we should be good to go. I'll just put some never sees on the shaft and slip that pulley back on. Make sure it doesn't get away from me here. It's a little bit more noise with the fan there, but still nice and smooth. Perfect. That's all it takes. Fresh lease on life, and should be good to run for a lot more hours.